Use the calculator to estimate all values of c as guaranteed by the mean value theorem. Then find the exact value of c by using this function. Find c between this interval. We start with the hypotheses. Step 1 is checking if it's continuous on a closed interval. Yes, f of x is continuous on a closed interval from 0 to 8 because it's a root function. We also figure it out by plugging in -1, realizing that its interval is continuous everywhere from -1 to infinity, including -1. The second step to the hypotheses is it differentiable on an open interval from 0 to 8? And yes, it's differentiable on an open interval from 0 to 8 because it's a root function. We figure out its derivative by rewriting it of its derivative, and we figured out that the derivative of f of x exists on a domain of 0 to 8, so f of x is differentiable on the open interval. The function satisfies the hypotheses. Now we move to the conclusion. Is there a number c in the open interval from 0 to 8 such that f prime of c equals the slope of the secant line? Therefore, we set our f of c equals f of b minus f of a over b over a, and we plug it in. We solve for it. We got over 1 over the square root of 9 minus 1. We changed it to 1 equals the same thing as 3 over 3 to combine with our denominator to make it easier for us. And then we got -2 over 3 over 8. We have to do some algebra here, so we flipped the 8 over. Remember, there's an invisible 1 down there, so we flipped it over, and we got -2 times 1 equals -2, 3 times 8 equals 4. Our answer simplified was -1 over 12. So that was our value found. Then we set our derivative to our value found, and we set equal to each other. You notice the 2. To cross it out, we multiply 2 on one side, and what we do on one side, we do on the other. We got -2 over 12, or simplified version, 1 over 6. So let's move that forward. We cross multiplied, we got 6 over x plus 1 with this exponent. Then we decided to rewrite it. Let's rewrite. Let's do the power of 2, multiply with the power of 2 to cancel out the square root, and then we got 36 equals x plus 1 with the power of 3. Then we decide to cube root at one side to the other side to cancel this out, and then we got x plus 1 and equals this function right here with the cube root, and our final x was the cube root of 3 over 36 minus 1 equals x. So our c found fits our interval. So that takes us back to our conclusion, finishing everything up. This is the mean value theorem, guys. Conclusion is there was a number c in the interval from 0 to 8 such that the derivative of c equals the slope of the secant line. We found by the mean value theorem there exists number of c in the interval of 0 to 8 such that the derivative of c equals the slope of the secant line. And we found our c value using the mean value theorem, which satisfies the conclusion because it's between our interval.